Alright, this is going to be a quicker video of rational expressions multiplying and dividing because multiplying with rational expressions basically is the same thing as what we've been doing. It's just more factors in the numerator and the denominator. And dividing is basically multiplying. It's just you have to rewrite the second rational expression before you can actually do it. So one review from what the previous video was talking about was simplifying a rational equation and then graphing it with a vertical asymptote. So this is because if you guys remember in the homework we had some problems that look like this. Remember, the vertical asymptote is found in the denominator. It's because it's where the function is not defined. So the vertical asymptote is when we set the denominator equal to 0 and we solve for x. So the vertical asymptote is at x equals -1. So we would graph that line right there. And then the horizontal asymptote, because this is a rational function, the horizontal asymptote is anything that's being added to the fraction. And so we would graph the line y equals 3. And then to graph a rational function, basically it looks like two curves where you're going to go like this, since this is a positive rational function because the fraction is positive. And then we would graph on this because it looks basically in the first and third quadrant. Remember, I told you the two curves don't have to be pretty. The best thing is being able to graph the two asymptotes. And so that is kind of a review over being able to graph these rational functions. Alright, multiplying. So we've got one multiplication problem where it's written in factored form. So we go right into finding the restricted values and then simplifying and then doing the multiplication. And then the second one, we got to write it in factored form. Then we want to find our restricted values, and then we want to simplify, and then we'll go from there. So restricted values, remember, that means we set every single factor in the denominator equal to 0. And so we say, okay, x cannot equal 1/3, x cannot equal -1, x cannot equal -1/2, and x cannot equal 1. So those are our restricted values, because if they x equaled those values, we would be dividing by 0, and that's a big no-no. We don't want to do that. So now, basically, what happens is when you're multiplying, it's like extending this line across, and basically you have 4 factors in the numerator and 4 factors in the denominator, and you're just looking for common factors that you can divide out. So we have x minus 1 and x minus 1. We have 2x plus 1 and 2x plus 1. And we have x plus 1 and we have x plus 1. And so we're left with x minus 5 and 3x minus 1 in the denominator, and so there's our final answer. Now in this bottom one, we have to factor, so this one we can factor out of 2. Let's look at some of the easier ones, in x plus 3. This one we can factor out of 10, and we're left with x plus 1. Then here, we've got quadratics without leading coefficients, so we're looking at factors of 16 that are going to add to 8. And we're looking at factors of 12 that are going to add to 7. So that's going to give us factors of, let's see, x plus 4 times x plus 4. 4 times 4 is 16, and 4 plus 4 is 8, over 10 times x plus 1. And extend our line here because of the multiplication. And then we have 2 times x plus 3 over let's see, factors of 12 that add up to 7. That's going to give us x plus 3 times x plus 4. And now we're factored, so let's just set our factors in the denominator equal to 0. X plus 3 equals 0, and ran out of room, so x plus 4 is equal to 0. So x cannot equal 1, negative 1, sorry. X cannot equal negative 3, and x cannot equal negative 4. So there's our restricted values, or our critical values, and now let's look for common factors that we can divide out. We have x plus 3 and x plus 3, x plus 4 and x plus 4, and then we have actually 10 over 2, which will reduce to 1 over 5. So if we simplify this, we have 1 times x plus 4, or just x plus 4, over 5 times x plus 1, and there is our answer. Okay, so now here is another problem that I had you guys do. Part of it is factored, some of it is not. Still, we can draw our line across. So let's finish factoring it. X plus 2 is factored. X squared plus 4x is not factored. We have a common factor of x. So this is x over x plus 4, or x times x plus 4. 3x plus 9 is not factored. That's got a common factor of 3. So we got 3 times x plus 3 and x minus 5. And then we need factors of 15 that are going to add up to 8. And so those are x plus 5 and x plus 3. And now we are set to find our critical values. So we don't set 3 equal to 0 because 3 does not equal 0. So we set x plus 3 equal to 0, x minus 5 equal to 0, x equal to 0, and x plus 4 equal to 0. So x cannot equal negative 3, x cannot equal negative or positive 5, x cannot equal 0, and x cannot equal negative 4. There's our critical values. And then we look to see what we can divide out. X plus 3 and x plus 3. And that looks like that's all that's going to divide out. So let's go ahead and write this out. We've got x plus 5 times x plus 2, and then 3x times x minus 5 times x plus 4. And unless the problem says to multiply it out, writing it in factored form is a perfectly acceptable answer. So you could multiply it out, so the polynomials are written in standard quadratic and then standard cubic, but this is actually the answer for the rational function as well. Alright, so what do we know about dividing fractions? Dividing fractions is actually, you have to rewrite it as multiplying by the reciprocal. But another way that I heard this phrase is keep it, switch it, flip it. So there's 3 things in this kind of equation. You keep the first fraction. So if we're using this problem right here, we would keep 2/3. We switch the division to multiplication, so times, and we flip the second fraction to 5/2, and then we go ahead and do it like a multiplication problem. So I would look at this and I see cross divide, but we'll do it the way, well, no, let's cross divide because we have common factors. We have 2 and 2, divide those out, and we have 5/3, and there's our answer. So if we do that same thing here after we factor everything, so this is going to become x minus 1, 2x plus 3 is all factored, x minus 5 is factored, divided by x squared minus 1 is x minus 1 times x plus 1, and x squared minus 25 is going to be x minus 5 and x plus 5. If we do the keep it, switch it, flip it, we keep this first fraction, so x minus 1, times x 2x plus 3 over x minus 5. We switch this to multiplication, and then we flip the second fraction, so we got x minus 5, x plus 5 times x, or over x minus 1, x plus 1, and now we've got a multiplication problem. Now we set our denominator equal to 0, so x minus 1 is equal to 0, x plus 1 is equal to 0, so x cannot equal 5, x cannot equal 1, and x cannot equal negative 1. There's our critical values. Now we look for what we can divide out. So x minus 5 and x minus 5, x minus 1 and x minus 1, and write what we have left. So we got 2x plus 3 times x plus 5 over x plus 1, and there is our final answer. Alright, so let's practice one more. Remember, factoring with rational expressions and rational equations should always be your first step, and that's why practicing factoring is so important. So this is a difference of squares again, so this is going to be 4x minus 5 and 4x plus 5 over 4x plus 5 and x plus 1, divided by x plus 3, x plus 2, and this is also a difference of squares, so we got x minus 1 and x plus 1. Okay, so now we got it factored, so we're going to do keep it, switch it, flip it. So keep the first one, 4x minus 5, 4x plus 5 over 4x plus 5, x plus 1 times, switch it, x minus 1, x plus 1 over x plus 3, x plus 2. Okay, it's multiplication. Let's find our critical values or restricted values. Whoops, that wasn't supposed to happen. So 4x plus 5 equals 0, x plus 1 equals 0, x plus 3 equals 0, x plus 2 equals 0. So x cannot equal negative 5/4, x cannot equal negative 1, x cannot equal negative 3, x cannot equal negative 2. And there are our critical values. So now we look to what we can divide out. 4x plus 5 and 4x plus 5, and x plus 1 and x plus 1. So now let's write our final answer. So we got 4x minus 5 and x minus 1 and x plus 3 and x plus 2. And there we go, simplified rational expression with critical values accounted for. And that is our division problem, and that is basically everything that we've practiced and what we were doing with multiplication and division, which really goes hand in hand with what we were doing before with just rational expressions and simplifying. It's just more factors to look at. Remember, factoring is key. So go ahead, practice these. You can practice these problems over again, but really practicing factoring is probably number one important thing when it comes to these problems.